All right, welcome back everyone. So today we're going to do a second part of section 9.3 that is about different types of reactions and how to classify reactions. So last time we learned how to write the reactions, and this time we're going to learn how to classify them. This is pretty easy. It's not too bad, and it's not going to be too long. So there's actually 5 different types of reactions that you guys need to be able to recognize. And I'm going to try and give you examples that will relate to something in your life, just to make this a little bit more relatable. So the first type that you need to know are called synthesis reactions. And the way we're going to write this out is I'm going to give you kind of like a general formula without any elements in it, and then I'll give you an example. So the general formula of a synthesis reaction is you take one thing and you react it with another thing and they combine. So pretty simple. An actual example of this is iron rusting. So a simplified reaction of what happens when iron rusts, because it's actually a little bit more complicated than this. But this is a simplified reaction. You see I've got one thing, this is like A, and another thing, this is B, and then they're going to combine and form a compound. So in the end I have just one chemical, but I start out with 2. So 2 things combine into 1. Now just a side note, you'll notice there's these big numbers in front of the compounds. Those are called coefficients, and we're going to learn about those either next time or the time after that. And a lot of you guys, when you were writing your equations, you were getting kind of freaked out because we weren't using these yet, and a lot of you knew that we needed to use these. So don't worry, we're getting there. This is how you make sure that there's the same number of each element on each side of the reaction. But don't worry too much about those for now. So this is a synthesis reaction. With these reactions, you can make a lot of weird dating analogies. So this is like a relationship forming, like 2 people become 1. Okay. Next type of reaction is called decomposition, and it is the opposite of a synthesis reaction. So in a decomposition reaction, you have one thing, so we'll call it AB, and it's going to split apart. Okay, so if you're going with relationship analogies, this one's like the breakup. A real example of this is the decomposition of hydrogen peroxide. This is the reaction you guys were watching in the yeast catalase lab that we did, the one where the yeast spheres rose to the top of the cylinder. That was hydrogen peroxide breaking down. So that reaction looks like this. Okay, and you can see we've got one thing at the beginning and 2 things at the end. So opposite of synthesis. Okay, number 3, we have single replacement. Now occasionally you will see this called single displacement, and it's the same thing. So whether you see displacement or replacement, it's the same thing. And the way that one works, it's a little more complicated. You have something like A plus BC, so 2 elements that are combined, and then they swap. So then you have AC plus B by itself. So A is by itself over here, but then B is by itself over here. So this is where the relationship analogies get pretty weird. This is like you steal someone's girlfriend or boyfriend. So it's like, here's the girlfriend or boyfriend. A goes in there and steals the girlfriend or boyfriend and leaves B alone, tragically. So the real life example of this reaction is a reaction called thermite that some of you might have heard of. It looks like this. So you take aluminum and you react it with iron oxide, which is the same thing as rust. And that makes aluminum oxide and solid iron. So this is a reaction people use to make pure iron. It can be used to weld railroad ties together. So here's a picture of someone using this reaction to weld railroad tracks. So that's the thermite reaction. And you can see it is a single replacement because the aluminum starts off by itself, but then the oxygen moves over there with the aluminum, and then the iron's alone. Okay, type 4 is something called double replacement or double displacement. And you can probably kind of guess what that's going to look like at this point. So the general formula for that is going to be something like AB plus CD goes to CB plus AD. So you can see A and C switch places. So this is not something that you see commonly in your life, but it's something you've seen in the lab before. And I'll tell you where you've seen it in just a second. So we take lead nitrate and react it with potassium iodide, and that makes lead iodide and potassium nitrate. And the place where you saw this is when we did that lab with the droplets on the sheet protector, and there was the one square where you mixed two clear liquids and suddenly it turned yellow. A lot of you probably remember that because it was kind of like shocking. So that yellow chemical that formed, that's lead iodide. So you mix lead nitrate and potassium iodide, which are both clear, and then it forms solid lead iodide. And then these chemicals are just still dissolved in water. So in case you forgot what that looks like, I have a little video of it that I can show you. It's very cool. Maybe. Here we go. So that is a yellow solid that's forming. I know it looks liquidy, but there's little solid particles in there of lead iodide. So that's a double displacement or double replacement reaction. Okay, last one is one that is very familiar to us, and it is combustion. So this is just burning something. I'm not going to give you, well, actually I will give you a general formula for this one. So with combustion, you're generally going to have a hydrocarbon. And when I say hydrocarbon, I just mean a chemical that's made out of hydrogen and carbon, which makes sense, plus oxygen, forming carbon dioxide and water. So whenever you burn a hydrocarbon, which is a lot of things that we use as fuel, are hydrocarbons, you make carbon dioxide and water. So our example for that is going to be natural gas. I already showed you this earlier on the last video, but I'll show you again. We've got a hydrocarbon. This is methane, natural gas. It's reacting with oxygen. And to do this reaction, like this is going to be a reaction where we're burning this. A lot of times when you're reacting something with oxygen, it's going to involve burning that chemical. And it produces carbon dioxide and water. And a lot of you will notice this is not balanced. So I need to balance it. But again, I will teach you how to do that later on in the next couple of days. So your assignment now is just going to be, can you look at reactions and recognize what type they are? It's really not too bad. and hopefully we put some of these in context, in the context of your daily life, so you can kind of realize that they do happen around you and they are important in your life. So hope you guys are still doing well and have a good day.